Hi, this is Abro and welcome to my channel. Today I'm going to start a topic named kinematics of machines. So in mechanical engineering there are many subjects like dynamics of machines, design of machine elements, then we have the machine designs and strength of materials and many more. Fluid mechanics, hydrolytic machines, thermodynamics, and here we are going to start numerical based on the kinematics of machines, and we know the kinematics of machines is very much similar to the engineering mechanics. So here we will deal with the one numerical here for the kinematics of machines, which is related with the IC engine. IC means International Combustion Engine. That is, in an internal combustion engine's mechanism, the stroke of the slider is 180 millimeter, and the radius of the connecting rod to crank is length is 4.25. The crank rotates uniformly at the speed of 600 rpm clockwise. So we have to find here the velocity and accelerations of the piston and the angular velocity with the angular acceleration of the connecting rod when the crank has turned 210 degree from IDC. So it is rotating in the clockwise direction over this clockwise direction from here. So it is total is 210 degree. It has rotated, and from here to here the distance it has rotated, that is 30 degree. So here whenever we are going to calculate anything, we have to first of all we have to take out what are the data given in the question. So here the data is given, the stroke is 180 millimeter. So we have to find the radius, that is 2r is equal to 180, r is equal to 90 millimeter. And now here is the speed. Speed is 600 rpm is already given over here, 600 rpm, and obliquity ratio is 4.25. This is all the data which is given in the question. Now what is the, we have to find the angular velocity of the crank, that is omega. Omega is very much is 2 pi n by 60, is very much common formula even in the dynamics of machines, design of machine elements, even electrical machines. We have this common formula 2 pi n by 60. We'll just put the value of n, that is the speed in rpm, 600 rpm divided by 60. If we divide, it will be 10, and it just will divide 600 to 60, it will be 10. And pi value we will take as 3.14. Pi we will take as 3.14 instead of taking 22 by 7, and if we just calculate, we'll get as 62.84 radian per second. Now we have to come to the main formula, that is velocity and the acceleration of the piston. That is very much easy. You have to just memorize the formula because everything is given in the questions, all the data, and you have to just put the data into the formula and get the result. So it's very much easy. Is what is the velocity of the piston, that is given by Vp, that is r omega into sine theta plus sine 2 theta by 2n, and acceleration of the piston formula is ap is equal to r omega square into cos theta plus cos 2 theta by 2n. So we have to just put the data into the formula. R is 90, omega is 62.8, sine theta, theta is given by 210, so we'll put 210. Sine 2 theta means 2 into 210 is 420 into divided by 2 into n, n is 4.25. If we just calculate using scientific calculator, we'll get the result as minus 2251.57 millimeter per second. And if we just convert to meter per second, it will be 2.251 into meter per second. So same thing, we have put this all the data into the formula, that is the acceleration of the piston, that is r omega square into cos theta plus cos 2 theta by 2n, and just we have put the value here. R is 90, omega square means 62.84 whole square, that is omega is angular velocity of the crank, thus cos theta is cos 210 plus cos 2 into 210 is 420 divided by 4 into 4.25. So we have to individually calculate from the scientific calculator what's the value of sine 210, cos 210, or sine 420 and cos 420. So we can just use the scientific calculator to calculate the whole value. We will get the result as directly. I'll go to the minus 265.972 meter per second. Actually we'll get the result in millimeter per second square, that is 265,972.09 millimeter whole square, and we have to convert into meter per second. just we have divided into 1000 by 1000, and it has come this value same as here. Now here is the, we have to find the second option, that is the angular velocity of the connecting rod. Angular velocity of the connecting rod is given by omega into omega Cp, that is omega into cos theta by n. So just we have to put the formula, we have calculated the value angular velocity of the crank given by omega, that is 62.84 into cos theta, theta is 210 divided by 4.25, that is coming as minus 12.8 radian per second. So same thing we'll calculate for the angular acceleration of the connecting rod, that is alpha Cp is equal to minus omega square sine theta divided by n. So minus omega square, that is 62.84, will be doing the square of this value into sine theta is 210 divided by n is 4.25. If we calculate this value in scientific calculator, we'll get as 464.58 radian per second. So I feel it's very much easy numerical, because we have to just put the formulas data into the formula and we'll get the result. So in this case we have to just only memorize these formulas and put these data into the formula and get the result. Whatever the questions you will get from the kinematics of machines, it will be very easy. The data will be changing, but the formulas and the way of calculating will be the same. So I hope you like my video. Keep watching the FIFA World Cup final today between the Argentina and Spain. And so I'll end my video here and we'll meet in the next video. Thank you very much.